Very good afternoon, dear viewers. Today, let me introduce myself. My project is actually mechanics or physics in engineering and scientist, and that is basically dealing with the Newtonian classical mechanics, the frictional force effect on free falling and without free falling objects that associate with the transitional and gravitational force, transitional and gravitational acceleration associate with the velocity and kinetic and rotational energies with the time duration, that how it can affect by this impact of the resistance or force. So here the first we introduce that how the differences of mass is not impactful for the impacting on the acceleration, or I'll say gravitational effect and transitional acceleration. It does not impact because there is no frictional effect. That means the air mass or resistance is zero. So whatever the mass that does not affect on the transitional acceleration, and that is equivalent to the gravitational acceleration. But in case of not free falling, that two masses that is actually here tied up with a rope, and it has impact on the tension and that transitional force and rotational force acting on it, that affect on the tension and transitional acceleration as well. So here you can see that due to the differences of masses, it impact on the transitional acceleration, and that difference of mass actually associate with the gravitational acceleration that determine the transitional acceleration. At the same time, the tension also impacting on these differences of masses, and that is for the pulleys with the two body that has different masses. In case of inclined surface, that two square shapes materials, actually one is hanging vertically downward, another is with the angle side, and that is rolling over these slides. But here also the acceleration actually varying due to the mass and the angle relationship, and the tension also associated with that. In case of different surfaces of the same masses, it also has the differences of the acceleration due to transition and the tension that is varying with the mass differences effect and gravitational acceleration effect. While in case of circular body that is rolling on the inclined surface, that here both the rotational motion and transitional motion acting, while the moment of inertia also acting on these circular bodies that is rolling over this rigid surface with certain angle that associated with a certain height. So here the moment of inertia, how impactful on this transitional acceleration or motion, that is we are discussing in the next slides, that has different shapes and different weights of the solid sphere, solid cylinder, and rings. It has different moment of inertia based on their principle of applications in the systems. And if so, then it has different moment of inertia, and definitely this different moment of inertia, how impacting on the difference of transitional acceleration. This slide can be shown that relationship. So here you can see that the higher the solid sphere has the highest moment of inertia, and it also has the acceleration transitional is the highest, while the lowest moment of inertia of this circular rings has the lowest transitional acceleration. And then this acceleration how transferred to the transition velocity, that is actually dealing here. You can see that the velocity actually the factor that associate with the energy conservation issues with the potential and kinetic energy. Here kinetic energy is two types. One is the transitional kinetic energy, another is the rotational kinetic energy, that is equivalent to the total potential energy. So the velocity is associated with the constant factor of beta. Wherever the beta factor or the um, coefficient of the moment of inertia factor is greater, definitely velocity is higher and smaller, and the beta factor smaller, definitely velocity is higher. So here you can realize that the lower moment of inertia actually impacting on the greater transition acceleration or velocity, and eventually it is making shorter time for falling from this same time rolling objects of different moment of inertia, because here the rotational kinetic energy is smaller for the smaller kinetic moment of inertia object, but the transitional kinetic energy definitely is higher, and that impacting on the faster moving from the rolling slides. So here we can finalize that the dynamics of rolling object that highlights the differences between transitional and rotational motion, that it emphasizes that how mass and radius actually affect the motion of rolling objects. The rolling object experiences both the transitional and rotational force, with transitional acceleration being independent of mass and radius of free falling object. The inertia associated with the rolling affect the kinetic energy with the solid spheres having greater inertia than the other spheres, and that definitely has the difference impact of transitional acceleration and velocity as well, and that making difference of the and the rolling time to fall to the grounds, and that the variation of acceleration of the rolling object depends on the mass differences and the angle of the inclination. In case of all other shapes, that is actually not free falling, that is actually tie up with these ropes. So in this conclude that the free falling object, the transitional acceleration and rotational uh, effect of it. For in case of uh, the difference mass spot is actually impactful for this free falling case. It does not have effect of transitional acceleration and gravitational acceleration, but in case of not free falling or resistive surface or interface, it does have a lot of effect with this variation of this mass, with the angle of inclinations, and as well as the rotational dynamics in case of moment of inertia. Thanks for your question. Thank you.